Okay, so yesterday we said that the vertex x coordinate is found at x equals the opposite of b over 2a. Okay, then the y coordinate is found by taking that x value and plugging it into the equation and evaluating. I just want to make sure that we've got that somewhere, that we remember how we find this point. Okay? It's not like geology. You're not getting another 60%.
I know. I'm happy about that.
That's a 50. All right, so in this particular problem, what is, let's identify the coefficients. What is the A coefficient?
Hold up, give me a second.
B.
It's a -1.
Okay, so here's the thing, and I know this can be kind of confusing maybe for some of us. So this is the generic quadratic equation. Every single quadratic is of that form, okay? And the A is, it's alphabetical because A, B, C. A is the term, or the coefficient for the x squared term. B is the coefficient for the x to the first term. And C is the constant, or the one that does not have an x with it. Okay? So the A term there, if we highlight things that way, is it easy to see that A is -1?
Yeah.
Okay, so A is -1. B is 2. And C is -5. Yes?
Okay, so on Monday the 21st and Tuesday the 22nd, for the online stuff, do you know what you're going to assign yet?
We'll talk about it here in a little bit.
Oh, you can send me your username for Call of Duty.
Well, you send me your Venmo, and you can just give me that $100 through Venmo then.
$100 lost though.
All right. So if I want to find the x coordinate of this parabola is going to be found at the opposite of b over 2a. Well, what is the opposite of b in this case?
-2.
-2 over 2 times a. What is a? -1. So then all we have to do is evaluate that. So we get -2 divided by -2, which is what? B1. Okay, so that evaluates 1. So that tells me right there, that was finding the x coordinate of our vertex. It happens at 1. Okay? Now, all we have to do is find the y coordinate. Find the y coordinate is to evaluate that. Okay? I'm going to take that 1 and we'll plug it in to the equation as the x value. So I'm going to have a negative, and then it'll be x squared. So x is in this case going to be 1. Plus then 2 times x, which is going to be 1. And then minus 5. And then we evaluate that. So what's 1 squared? 1. And then you take the opposite of that, so -1. We got plus 2 times 1. And then we got minus 5. So what's -1 plus 2 minus 5? -1 plus 2 is 1, right? Minus 5 would be -4. So the x value was 1. The y value is -4. And all that does is find us that point. Now, if you are an individual that struggles with that evaluation, which my hope is that we continually get better and better at it, but we can use Desmos.
I can't use this. I'm not got a computer.
So, well, once you have it.
Don't have one. Sorry.
If we say negative x squared plus 2x minus 5, hit enter, and then say x equals the one that we found, does it give me back the y value to be negative 4 in that case? So you can use that, okay? Does anybody have like one of these calculators that they, like the TI-83 or 4 that you have a handheld that you use?
I had it, but I don't got a computer.
Shut up. Does anybody have a handheld that they would use?
I usually have my computer in my hand. I don't have it.
Does anybody use this one when they actually have their computer?
Yeah.
You have that? Okay. So what? This is a graphing calculator. So I was just trying to show. I was going to show you how you could generate that same thing that Desmos does for us if you were using that calculator. But since nobody has the handheld,
I have a handheld. Love it.
we'll maybe take that for
Love it.
a different time. Stop talking. All right. So we're going to plot that point. 1, negative 4. 1, negative 4, right there.
What's wrong with you?
Okay. Okay. Now, where is the axis of symmetry going to be? Yep. So it's a vertical line that always passes through the vertex. So that is x equals 1. All right. Now, we need one other point. And the other point that we use is the y-intercept. Okay? The y-intercept, what is the x value of any point on the y-axis? What is the x value of any point on the y-axis? 0. So my y-intercept is going to be found when the x in that equation is 0. So if I plug 0 in right here, doesn't that go away? Does that make sense? 0 squared is 0. Take the opposite, just 0. If 0 is put right here, doesn't that go away? It gives me 0. What's 0 plus 0 minus 5? Negative 5, right? So now, when x was 0, y was negative 5. So I'm going to plot that point. That's my y-intercept. Now, if that's the case, that distance right there from my axis of symmetry to that point should be reflected on the other side. So that's going to give me then that point there, which would be 2 comma negative 5. And how many points do I need? What's the bare minimum points I need for a parabola?
3.
3.
We have 3 too, so that's fine.
So we can graph that. Now, I do a crappy job of getting through those points, but your parabola is going to touch those 3 points. And then it extends forever. So one thing I do see from people sometimes is this. They tend to just graph that, okay, which is somewhat incorrect, because what we do there is we restrict the x values, we restrict the domain where we should extend it and put arrows on it so that we know it shows that parabolic behavior forever then. Is this something we can do? Okay, I want you guys,
Alright, you're welcome.
no, we're not done. I want you guys to go through, and I want you just right now, real quick, through these 4 things, just write on each one of these, write down what A is, write down what B is, write down what C is. Do that for each one right away.
That's it?
2.
Right now.
No, we're done.
Well, with that task.
Dude,
You're getting my hopes up.
we got like 20 more minutes.
All right, so let's start at number 2 here. What is A for number 2?
-3.
-3. What's B?
12.
12. And C?
1.
1. What is it for number 3? A is
Take mine too.
3, -9, 2,
6, -5.
and then 6, 6,
First one though.
-5. Okay, first one. Why is the first one hard? What's A? 2. So now it's because there's not 3 parts, right?
B is 1.
0.
B is 0. And C is 3. Because y equals 2x squared. Okay, every one of these is like ax squared plus bx plus c, right? So we really have, what is 0 times x? 0. So no one ever writes this, so this would be the way we write this. But nobody ever writes plus 0, right? Like you just get rid of it. Because we know it doesn't affect the sum. So there, when you're missing something, the b value in this case would be 0. Now, we've done this one before. We've actually, in the previous notes, asked where is the vertex. So remember what 2x squared does. So x squared would be that, right? Okay. We talked that 2x squared would be a skinnier version of that. Okay. Do we remember what that plus 3 does? Moves it up how many units? Okay. So that would mean my vertex is located where?
Now?
Yeah, where would that vertex right there be? 0, 3. Okay, so let's go through the algebra and see if that happens here. If we go x equals the opposite of b over 2a, what is the opposite of 0? 0. Divided by 2a, 2a would be 4. What's 0 divided by 4? 0. Okay? Now, if I plug, so then once I have the x value, I need to plug that back in here to find the y value, right? When I plug 0 in, doesn't that thing there go away? And you're left with 3, correct? Y is 3. So you would get 0, 3. So at the beginning of the class yesterday, I said, what we've already learned 2 days ago, 3 days ago, 4 days ago, can still be done using this up. So this is kind of like the safety net, the catch-all that will allow you to find the vertex all the time. But those special cases that we were working on earlier, the reason we talk about them is because of this situation. I was anticipating us to struggle in realizing what B was because it wasn't written down, right? So we had to know that it was 0. But this will work. This formula will work for all of these, okay? So help me out here on this next one. What is the x coordinate of the vertex here? X equals, it's going to be opposite of B over 2a. So what's the opposite of B? Negative 12. And then 2 times a would be, okay, so negative 12 divided by negative 6 gives us what? 2. So the x coordinate is at 2. Okay, now I got to find the y coordinate, right? Okay, so I'm going to take that and plug it back in for the x's there. So it'd say y equals negative 3 times 2 squared plus 12 times 2 plus 1. Okay, what is 2 squared? 4. And then you got to multiply that by negative 3, so it gives me negative 12. This is going to give me positive 24. And then add 1. What will that give me as a total? 13. Good. So the x value is 2. The y value is 13. There's your vertex. Where is your axis of symmetry?
2.
Yep.
On it.
Careful. X is 2. X equals 2.
Yeah.
Okay? So your axis of symmetry is always the x coordinate of your vertex, right? Alright. You guys do the next one.
The
Sure.
function of x. Bro, I literally did those first two while you
What
guys
if I-
were doing
what
the
if I
ABCs.
say-
I don't know the function of
He
x.
loves doing.
Well, so by definition, y equals f of x. Those two things
Oh, so
are the
it's
same.
the same way. So I stopped for no reason.
Yep.
Bro.
Yep. And that's why I do that kind of stuff, because I was the same way. Like when I was in school, it was confusing for me why they would hop back and forth between y and f of x, because it was never explained until I learned on my own that the reason they do this, the reason they change from y to f of x, if they just say y, I don't know if that thing is a function or not. I don't know if that passes the vertical line test. But when they use that notation, it is the same thing as y, but now it gives me more information. It tells me that the graph does pass the vertical line test. Okay? But we treat it the same exact way as we treat y.
Were you recording during that?
All right, so if we find x, it's the opposite of b. So positive 9 over 2a. Okay, so this is going to be 9 over 6, right? And that gives me 3 halves. So here's what I want you guys to do when you get situations like this, because if I'm going to evaluate that to find y, it's going to be 3 times 3 halves squared minus 9 times 3 halves plus 2. That's going to be difficult, right? Squaring fractions and all that sort of thing. So that's where I want you to grab Desmos. Type in 3x squared. What would I do?
Yes.
I would do the normal math. Do it by hand. Okay. So there I'm going to get, so I type it into Desmos, and now I want x to equal 3 halves. Okay. And now I really want this as a decimal, or sorry, as a fraction. It is as a decimal now. Click that little button there, it'll toggle it to a fraction. So negative 19/4. So the vertex happens at 3 halves, negative 19/4. Okay.
Wait, you want us to do the fraction? Because I did it just.
If you leave it, so
Yeah, what if
so that's not terrible as a decimal. But what if my denominator was a
That was negative 3.
huh?
That was negative 3.75.
4.
Bro. I literally did not have a calculator.
I'll look at it. But if the idea is, you say, why do I leave it as a fraction? The idea is, that is, as a fraction, it's the exact answer. If the denominator was a 3, then it would be 19/3. So the decimal part would be like 0.33333 or 0.666666. And that would be, we'd have to round that, right? And once we round it, we really don't have the vertex. We're very close to it, but we don't have the line. Does that make sense?
Yeah.
Let me see. You saw the calculator?
I mean, I should do it on
That's so good.
What? Ooh, wow.
Let me show you something this calculator that you can do.
When you get bigger,
Oh, how much Kool-Aid?
so you're just gonna shop one day.
You'll never know. I like the kids' meals.
So,
You have kids meal?
Yeah, it's like little
okay, so you can
separated. I'll say, they really do have kids. They have
you would
kids
go
too. I'll just talk to this.
3x squared.
I'll just start with
Ooh,
X.
Nice.
Let's do it this way. So we can take x,
you guys are real good at that.
Where'd it
this
go?
STL button,
I gotta
and
see.
then we're gonna store it as 3 halves.
Hey, shut up.
All right, guys.
So
You named your truck Corvette because you wish it was a Corvette.
STL.
I actually don't want a car.
Okay, so it's 1.5.
Your truck might as well be a
So
car.
what if that means that next time I take x, it's gonna put 1.5. So if you go
Don't
Have
worry
you
about
seen the
it.
night sales truck? It's like, it's the same as Austin's,
No,
bro.
it's actually not. So.
Yeah, it's a freaking Ford Ranger.
minus
There's a
9x
4-wheel drive and it's not extended garage, so you can.
plus 2.
My SUV is nicer than Austin's truck.
Okay, so I can do it.
I said, do you have a back seat or do you have like those seats that like come down?
Alright, do that last one on your own. And then we'll be done.
Okay.
Find the vertex, find the axis of symmetry. Okay, so x equals opposite b over 2. What is b? 6, so we'll have negative 6 up top.
We'll meet him at 6.
And then 2 times 6 on the bottom. So what's that going to change to?
Let's go live on Facebook and do.
So negative 1/2, right? Okay. So then y, or f of x, is going to be 6. Folks, let's pay attention. We'll put negative 1/2, square that, plus 6 times negative 1/2 minus 5. Now, I want to demonstrate, because you asked, what would you do without Desmos? I just want to demonstrate how you go through this without using a calculator and how that can be kind of messy. Negative 1/2 squared, what you do is you square the top number, you square the bottom number. So it's going to give you 1/4. Then you got the 6 out front. This is going to give me, when I multiply fractions, I go straight across the top, straight across the bottom. So it's going to give me negative 6/2. And then minus 5. This is going to then change to 6/4. Multiplying fractions, straight across the top, straight across the bottom. Then I have negative 6/2 and minus 5. Well, if I'm going to subtract fractions, what do I need? Common denominator. Common denominator here is going to be 4. So I have 6/4 minus then 12/4 minus then 20/4. So now 6 minus 12 is what? Negative 6? Minus 20 more is negative 26. They both divide by 2. Down to negative 13/2. Where if, just think about the convenience of Desmos. If I just type in on Desmos, 6 plus 6x, and then minus 5, and then say, okay, x needs to be negative 1/2. Does it give me negative 13/2 right back? Okay. One thing you can do, so here's what I also really like about Desmos. We just did 4 problems, right?
We did.
And they were all very similar, correct? What Desmos can allow you to do is say, okay, I'm gonna type in ax squared plus bx, then plus c. That's the general format for any quadratic, right? Now, think about this last one. We just did, it was 6 for A, 6 for B, negative 5 for C, right? I can actually hit A equals 6. I want B to equal 6. And I want C to be negative 5. Is that okay with everybody? I gotta hit C equals negative 5. Now watch. If I ask this thing to go, what is the opposite of B over 2A? Does it give it to me? Okay. Now, I can also say, now I want that value, that's my x value that I want. So if I hit x equals there, it gives me the opposite of 1 or negative 1/2, but come back up here. I wish I could show all, there we go. If we have that, okay, come back up here, does it automatically put the negative 13/2 in? So we can almost write a computer program here that allows us to find all of these results instantaneously. Because now let's go to the next question. Let's go, or go back up to one that we've already done. If A is 3, so I just got to now put 3 there. If B is negative 9, so I put negative 9 there. And if I put C as 2, you see it automatically gives me the x coordinate, and it gives me the y coordinate. Does that kind of make sense? Okay, so you can write something like that. You do it just like that, and it will give you the algebra, or will do the algebra for you, the arithmetic mainly, to find that vertex. Okay. We'll stop there for today. Like I said, I'm going to 6th period by myself, open up some assignments.
Stay over here so then no one can see you.
That's what I do.
Climbing through the window.
But I was like.